Alright guys, so today all we're going to be doing is solving for x for some logarithms. Now you need to note that some problems will have no solution, so just be aware of that, and we will see what we get. So, the only thing we have to do that for these is we start at the base, remember, we need to rewrite it as an exponential first. So this is going to be 3 to the 4th equals x. Okay, so what does x equal? 3 to the 4th gives me 81. So we get 81 equals x. And that's your answer. Right? Okay, so do number 2. 2 to the 5th equals x. So 2 to the 5th is 32, so x equals 32. Not too bad, right? Okay, so number 3. 3 to the x equals negative 3.
So would you plot a negative 1 to the
Okay, well let's think about it. If I have an exponential equation, will my answer ever be negative? No, right? Can you think of any number you could plug in for x to give me a negative 3? There is no number. So what do we call this? No solution. So if you are ever getting something equal to a negative, it's automatically no solution. Okay? Because remember, this inside part has to be positive, and just positive. It can equal 1. Okay? Alright, so number 4, log base 2 of 2 equals x. So that's 2 to the x equals 2.
Plus 1?
So this is the same as 2 to the first power, so x equals 1. You guys feel like geniuses yet? Number 4. Log base x of 64 equals 2. So this is x to the second power equals 64. Or, yeah, 64. Okay, so how do I get rid of that square? Square root it. So x equals 8. Yep. Bless you. Number 5. 1 over 25 to the negative 1/2. So make sure you put it in parentheses and then raise it to the negative 1/2 is equal to x. Okay, before we start worrying about the fact that our variable or our exponent is a fraction, let's worry about that negative first. If my exponent is a negative, what happens? We flip the base, right? So this is going to be the same as x equals 25, and then that exponent becomes?
A negative 2? What is a 2?
It just becomes positive 1/2. Nothing about the exponent changes except the sign. The only thing we flip is the base. Okay, so then x equals what? If I have an exponent of 1/2, what am I actually doing? Square rooting. So this is going to be square root of 25, which is 5. Okay, so whenever you have a negative exponent, all you need to do is flip that base, and then the exponent becomes positive, but it still stays the fraction. Okay, nothing about the exponent changes except the sign. Okay. Okay, so number 6. This is 3 to the x equals 0. No, what, okay. Can you think of any exponent that will ever give you 0? Nope, so it is 1. 3 to the 1 is going to give me 3. 3 to the 0 is going to give me 1. 3 to the negative 1 gives me 1/3. I'll get really, really close to 0, but will I ever touch 0?
No.
No, so we have no solution here. Okay, so what about 7? That's going to be, how would we write that as an exponential? X to the negative 1 equals 4. Okay. Alright, let's get rid of this exponent. What can I raise this side to make this a positive one? You guys have any ideas? Okay, if I raise both sides to the negative 1, what's negative 1 times negative 1? Positive 1. So that's going to make this just an x, right? And what's 4 to the negative 1? 1/4. So it's really the same as what we did in the last unit, multiplying by the reciprocal, right? The reciprocal of negative 1 is still negative 1. But when we multiply both sides by negative 1, that's going to cancel out this guy to make it a positive 1. Okay. Moving right along. I swear it's true. Are you checking it? Okay. Number 8. This is 5 to the what? X equals 25√5. Okay, let's practice with these some more. So that's going to be 5 to the x equals, what's 25? 5 squared times, what's square root of 5? 5 to the 1/2. Okay, what do I have to do with those exponents still? I need to add them. So what is 2 plus 1/2? If I multiply both sides by 2, this is going to be 4/2 plus 1/2, which gives me 5/2. So this is 5 to the x equals 5 to the 5/2. Right? So x equals 5/2. Okay. Okay. Log base 3 of 27 squared equals x. So that's going to be 3 to the x equals 27 squared. Okay. Which one am I going to change here? Am I going to change the 3 to the x or the 27 squared? Good, the 27 squared. If I change the 3 to the x, that changes the entire value of this thing, right? Rewriting 27 squared doesn't actually change the value of the number. We're just rewriting it. So this is going to be 27. We want a base of 3, so that's 3 to the what? Third. All of that squared, right? And what do we do with those exponents? Add or multiply? Multiply. Whenever we raise a power to a power, we are multiplying. So this is 3 to the x equals 3 to the 6. So x equals 6. Yeah, a power to a power, you're multiplying. Multiplying exponents, you add them. Okay. You guys still with me? Okay. Negative 27 to the 1/3. Make sure you put that negative 27, well, I guess it doesn't matter, in parentheses, equals x. Okay, if my exponent is positive 1/3, what does that mean I am doing? Am I going to flip it or am I taking a root? I'm going to take a root. So this is 1/3, so we are taking the third root of negative 27 equals x. I can. I can't in a square root, but can I in a third root? If I multiply a negative by itself 3 times, it's still, no it's not.
Well, I meant
If it's a square root, yeah. Okay, so 27, what's the cube root of 27? 3, and if it's negative 27, that means my answer is going to be x equals negative 3. Because let's think about it. Negative 3 times negative 3 gives me positive 9. And positive 9 times negative 3 gives me negative 27. So we can have a negative if the index of that root is an odd number. Okay? And our answer then will be negative. You guys remember that? That was from before winter vacation. Last one. X to the 3/4 equals 27. Okay, what do I do here? You guys remember from last unit? We don't flip it. We multiply by the reciprocal. So we raise both sides to the 4/3 power, because then these guys will cancel. So that gives me x equals 27 to the 4/3. How can I rewrite that? Cube root of 27 to the what? To the 4th. Okay, so x equals good, 3 to the 4th. So x equals 81. So this is just putting pretty much everything that we did in 8A. Now we're putting it all together but with logs. So it's all the exact same rules that we did in the previous unit. Okay, nothing really new.